So what is induction? Induction means it's a way to prove something. So we have a problem right here. So we're going to solve it using induction. So first step is to find a base case. That's the first step. Then when we have a base case, what we're going to do is we're going to say, okay, we have the base case, and then we're going to say the next one is also true. So base case means that one case is true, any case, one case is true, and then we're going to say that we're going to suppose that n is true. That means that n plus 1 also has to be true. Okay? So this, and then we're going to say, okay, now this is n. Now this is n. Let's suppose that n plus 1 is true. So if you just have one base case and you can say you're gonna then you find the base case, then the second step is say n is true, so we're gonna prove n plus 1 is true. That means it works for all cases. So that's one way to prove something. It's called induction. So for this problem, we have to show that this is true for all natural numbers n. So for all n natural numbers n, we're gonna say we have to prove this is true. Okay, and so we're gonna do one base case and say n is equal to 1. So we're gonna plug in 1, and what happens if you plug in 1? You just plug it in for n, and you have sine of 1x is less than or equal to sine of x, and that's true because they're just equal to each other. This is less than or equal to. Okay, now we got the base case. We did this. Right now we have to do the second step for induction. To prove it, we have to so we're gonna suppose that n is true, and then we change the proof to prove that n plus 1 is true. So we're gonna assume that the n is true. We're gonna assume what we want to prove is true, which is that sine of nx is less than or equal to n sine x, which is what they ask, right? Instead, now what we're going to do is this is our assumption. It's called the inductive hypothesis. Inductive hypothesis. We're just assuming that it's true, and we're going to instead try to prove that the n plus 1 is true. And if the n plus 1 is true, that means this whole entire thing is true, right? Because this is how the induction works. You find the base case, find one case, and you prove that everything after the base case is true. That means it works for all cases. Works for all cases. It means it's true. So for all natural numbers n. Okay. So we have our inductive hypothesis right here. It's right here. It's that this is our inductive hypothesis. We can use it whenever we want. But now our proof is no longer that. This is our new proof. We want to prove this. And if we can prove this, then it's true. Then the original problem is true. So we need to prove this. This is our new proof. The first thing we're going to do to prove it is that we're going to just distribute the x. So we're just going to distribute it here and here. So we will get right here, we will get sine nx plus x, right? So we just distribute the x, and this is what we got. So this left side right here, we're just focusing on the left side. Focusing on the left side, we see that this, and this are equal. We just distribute the x. Okay? Now, using a trigonometry formula, it's right here. It's just a trigonometry formula. Right here, we just use it, and then we're allowed to make this into this right here, using our trigonometry formula. Okay? So we applied the trigonometry formula, and we made the left side into something new now. Okay, now we have this. This is our left side. Remember, this is equal. Now what we're going to do is we're going to use the triangle identity. This is the triangle identity right here. And we're going to take this left side again, what we got right here, and we're going to apply it. We're going to just kind of use the triangle identity. That's all we're going to do. And we're going to see how it fits. So we see that this is our A, this is our B, and this is how it looks when we apply the triangle identity. So we just got this left side, and we use the triangle identity, and we broke it up. This is our A, this is our B, and it's going to be less than when they are separated. So A plus B is less than or equal to the A plus B when they're separated. Okay, so now we have this inequality right here, which is just using the triangle inequality. Okay, now we're going to say this left side right here. Remember that it was actually just equal to the one in the beginning. It's equal to this, right? This is all the left side. This is all equal to sine of n plus 1x. So we're just going to replace this with this huge side right here. Just replace it. Okay, so just we're gonna replace this with this. Okay, and then what we do, we have this left side right here, right? We just replaced it, and the right side stays the same. Okay, now we're gonna try and fix the right side. So what can we do with the right side? So actually what we can do with the right side is we're gonna see something. We're gonna get rid of both cosines because of these properties right here. What we're going to do is we're just going to eliminate the cosines. Just get rid of them. Why can we do that? Because the range for cosine is between -1 and 1. Right here, -1 and 1. This is the range for cosine. It means that cosine is always going to be less than 1. If cosine is always less than 1, that means that sine of nx, if we replace the cosine with the number 1, it's going to be greater than. So we're gonna make, if we can basically, the general principle is we can replace this right side with anything bigger than it. So anything bigger, if we find something bigger, so for example we can replace it with this plus 1 because the inequality will still be true. So this right here is greater than this. That's why we can replace it. And why is this greater than this? Well, because of this example right here. If we're basically just replacing the cosine with the number 1, and if we replace it with the number 1, right, then it becomes bigger, because so because we can just replace it with 1 and it will be bigger, because cosine of anything is always less than or equal to 1. So we can just replace it and get rid of the cosines. Now we have this inequality here, and what we will see is that now it's time to use our inductive hypothesis. So you know how in the beginning we assumed it? We can use it now to help us prove. So in the inductive hypothesis, we see that sine of nx is less than n sine x, right? So we're going to take the sine nx, and again we're going to replace it with something that's bigger. We can always do that because the inequality will still be true. Since we know that n sine x is bigger than sine nx, we're just going to replace it because it's bigger. And we're basically making the right side bigger and bigger and bigger, and the inequality is still true. So we replace this with this because this is bigger according to our inductive hypothesis. So we just apply our inductive hypothesis, right? This is the step where we apply the inductive hypothesis. Okay, and then we see that n sine x plus sine x, this is the same thing as n plus 1 sine x. Actually, it should be written like this. Should be written like n plus 1. It should be like this. N plus 1 sine x. N plus 1 sine x. Yeah, because this is n and this is 1, so it becomes n plus 1. So therefore, we proved it. So now the proof is complete. This is a proof by induction. Proof by